Good evening, students. Are you able to hear me?
Yes.
Others are joining. Any idea? Okay, we'll get started. So yesterday, what was the last topic that we saw? So today, what was the topic I told I'll start with?
Sir, Pascal's law.
Pascal's law was last concept. Yeah. So now we will start with barometer, right? So did we see that concept yesterday? So write down the heading as mercury barometer. Okay, so this is going to be the next topic. Okay. So as the name suggests, right, bar is a unit of pressure and meter is a device which is used to measure the value. So if we are able to think of a device which is able to measure the pressure at a particular point, then we can call it as a mercury barometer. Mercury is a substance that is used in this particular measuring device. Okay. So how is it going to look like? If you observe, what is the shape it is taking? So you have a 1 meter long glass tube, right? So you have a 1 meter long glass tube and there is dry mercury taken inside it. Okay. Now what will happen is, let's say you take the glass tube and completely fill it with mercury. Now what you do is you invert it. Okay. So when you invert it and put it into a vessel like this, then the mercury will start flowing and it is going to form a layer like this. And this process will stop when there is a particular height from the surface, from the outer surface of mercury that is getting generated. Okay. Are you able to understand? So if you observe, what will happen here is, here there is a vacuum that is going to get created. Okay. So what we can say is, if you observe, there are 3 points that are considered. One is near the surface, one is at the bottom of the tube, and one is C, which is exposed to the atmosphere. So the surface which is exposed to the atmosphere has a pressure of PA, right? Now, we know that the pressure at point B will be equal to pressure at point C because they both are at the same depth. Or I can say at the same horizontal level, the pressure is going to be the same everywhere. Okay. So PB will be equal to PC will be equal to the atmospheric pressure. So this is the first point to be noted. Okay. Now, what is the relation between PA and PB? So PB will be equal to pressure at A plus rho GH. This we saw yesterday because of the pressure due to depth. Am I right? So, but what did I say? PA is going to be equal to 0. When PA is 0, we will substitute PB is equal to rho GH. So from this, if I call this as 2, from 1 and 2, what is the important conclusion that we can draw? PA will be equal to rho GH. PA means atmospheric pressure will be equal to rho GH. And what is the value of atmospheric pressure? Atmospheric pressure is going to be 1.013 into 10 power 5 Pascal is equal to density of mercury is going to be 13600 kilogram meter per cube. Sorry, kilogram per meter cube. Into G is going to be 10 and height is H. So if I take this value and calculate the value of height, I will get 0.76 meter or 76 centimeter. So what does this mean is, first let me complete, then you can copy. So the meaning of this is 76 centimeter of mercury is equivalent to 1 atmospheric pressure. Okay. So did you understand?
Yes.
So please copy it.
Sir, 1 atmospheric pressure, is there any unit for that?
Newton per meter square.
Okay, so
Newton.
1 Pascal of atmospheric pressure.
1 Pascal of atmospheric pressure. No, not like that. So 1.013 into 10 power 5 Pascal constitutes to a value called as atmospheric pressure.
Sir, can you explain?
See, that is a
Okay.
fixed value. 1 atmospheric
Okay.
pressure's value is a fixed value, 1.013 into 10 power 5 Pascal.
Okay.
Yeah. Like how the
Okay.
density of mercury is 13,600, the value of atmospheric pressure is this value.
Okay, sir. Thank you.
Yeah.
Sir,
Hmm.
sir, can you please explain it once again, sir? This thing.
See, you take a glass tube of 1 meter length, fill it with mercury. Okay. Hold it at the top and then invert it and place it into an empty vessel. So what will happen is the mercury will start flowing, right? When it starts flowing, the level inside the glass tube will decrease and the level inside the glass container will increase. But somewhere this process has to stop, right? So when it is going to get stopped, then you will have a shape like this form. This is called as a meniscus. Okay. So you will have a shape like this that is formed, so that we are trying to calculate what is the value of pressure at point B. If at all we want to calculate what is the pressure at point B, then what I can do is, see, inside what was there initially, it was only mercury that was present. There was no air molecules or something present at the top. So when the mercury level has come down, what will get created at that point? It is vacuum. Right. So there is a particular height associated with this particular mercury column inside whom? Inside the glass tube. Is that point clear? So this height is getting associated inside the glass tube in such a way, we are taking 3 reference points. One is A, one is B, and one is C. So pressure at point A is 0 because there is nothing above it. Whereas pressure at point B, according to the concept of pressure with depth, is going to be PA plus rho GH. So when the pressure at point A is going to be 0, then PB will be equal to rho GH. But when I draw a horizontal level, at the same horizontal level, pressure is going to be the same at every point. Means if you take a particular water surface, if you calculate the pressure at any point, if I call them as P1, P2, so on till like this, pressure at 1, pressure at 2, pressure at 3, so on till pressure at n will be the same, provided it is at the same horizontal level. So pressure at point B will be equal to pressure at C. But tell me, where is C exposed to? It is exposed to the atmosphere, hence it will be PA. So PB will be equal to the atmospheric pressure, but PB is also equal to rho GH. So equate both and calculate the height. So when the height of the mercury column becomes exactly 76 centimeter, the pressure it will exert at the surface below it is going to be 1 atmospheric pressure. That is the meaning.
Sir, can you move to the next slide?
Thank you, sir.
Okay. Next. One minute. Okay. Leave. Okay, write down the next heading as open tube manometer. So next heading is an open tube manometer. So it is basically a simple device which is used to measure the pressure of gas that is enclosed in a vessel. Right? So it consists of a U tube, right? A U-shaped tube, right? Containing some liquid. One end of the tube is open to the atmosphere. So you're able to see one end of the tube is open to the atmosphere and the other end is connected to a vessel. Clear? Are you clear with this? So I repeat it again. Why is a manometer? See, wherever you see this word meter, right? Meters are generally measuring devices. So it is a simple device used to measure the pressure of a gas enclosed in a vessel. So what does it contain? It contains a U-shaped tube. This is very important because we will see the same concept in another topic called as Venturi meter. At that point, there will be a manometer which is a part of the circuit. Part of the system. Okay. So there, this U-tube will be there. Inside the U-tube, the liquid will be placed in such a way that one end of the tube is exposed to the atmosphere and the other end is connected to the vessel. Is that clear? So what we are
Yes,
trying
sir.
to do, very good. So what we are trying to do here is we are taking 2 points A and B at the same horizontal level. So from the point C at a depth H, there is a point B. Okay. Now tell me what would be the relation between all the 3 parameters. Can I say pressure at point A will be equal to the pressure at point B? Accepted.
Yes.
But what is going to be the pressure at point B? It will be the atmospheric pressure at the top plus what should get added to it. Plus
Atmospheric pressure at the bottom, sir.
no, there will be no, see, atmospheric pressure is going to exist only where it is exposed to the atmosphere. Bottom atmospheric pressure. What is happening? There is a depth, no, you're forgetting that concept. So there is a pressure due to depth that is going to act of how much value? Rho GH. Clear?
Clear, sir.
That's it.
Yes, sir.
So that's it. This is the only mathematical equation that we have. Here, only point to be noted is rho is going to be the density of the liquid. That's it. And H is going to be the depth below the surface C. Clear? That's it. Okay, shall I proceed? Yes or no?
Yes, sir.
Yes, sir.
Now, the next concept that we are going to see is buoyancy. So, if you observe, right, see, concept is very simple. When I have a container,
Sir,
tell me,
can you show the previous slides, sir? Thank you, sir.
done.
Yes, sir. Thank you, sir.
So, when you have a liquid into which you immerse a solid, what are you doing? Inside a liquid, you're immersing a solid. Okay. When you try to immerse it, the solid by default will have some weight associated with it. Right. So when solid is trying to enter into the liquid, what will happen to the liquid on the other side? It will start rushing in the upward direction. At the same time, the liquid will not try to have any object inside it. Rather, it will try to push it outwards. Right. So when a solid comes in contact with a liquid, then the liquid will start exerting an upward force on the object, which is called as upthrust or buoyant force, right? And this kind of a phenomena where the liquid is able to exert an upward force is what is called as buoyancy. Is it clear? Is it clear?
So,
Sorry?
buoyant force is very
Your voice is breaking a lot. Can you just drop me a message in the chat box? So buoyant force is a reactive force. Yes, we can say that. Right. So since we are saying this force, it's a vector quantity, means it needs to have a direction associated with it. So write it down. Force of buoyancy, right? Force of buoyancy acts through the center of gravity, right? Force of buoyancy acts through the center of gravity of the displaced liquid. Center of gravity of the displaced liquid, which is also called as center of buoyancy. Okay. So this is a very simple concept. Based on this, there is another important concept that we are going to discuss, which is called as Archimedes principle. which is very, very important. So you would have studied this Archimedes principle in your lower grades. So what does it state? When a solid is partially or completely immersed in a liquid, then the weight of the liquid displaced is equal to the buoyant force. When a solid is partially or completely immersed in a liquid, then the weight of the liquid displaced is equal to the buoyant force. Right? So this is, in your lower grade, you would have learned something like this. The volume of the liquid displaced is equal to the volume of the solid immersed. That is obvious. How much ever is the volume of the solid that has got in, that will be the volume of the liquid that has got displaced. Whereas in this case, what is going to happen? When a solid is partially or completely immersed in liquid, weight of the liquid displaced is equal to the buoyant force. Okay. So when we say this, listen. Let us say there is a solid that is completely immersed into the liquid. Okay. So let's say there is a force acting from the top as F1, and there is a force from the bottom, which is F2, and there is weight acting, which is mg. Okay. So here what I'm doing is rho s, I'm using it for the density of solid. Rho L I'm using for density of liquid. Right. Now, under equilibrium condition, what can I write? Under equilibrium condition, what can I write? F1 will be equal to mg, sorry, F2 will be equal to mg plus F1, which implies F2 minus F1 is equal to mg. Can I write it in this way? Yes or no? Now, let us say this height is x. Okay. And let me say that the side of this shape is h. Right. So having said this, what will be the force F2? F2 will be, so F2 will be the force that is coming into picture due to the pressure acting at a depth of how much value? Due to the pressure acting at a depth of how much value? From the surface, what is the depth to the bottom of the solid? So that is rho L, density of liquid, into G, into, can I write it as H plus X minus, sorry, H plus X into, so this is the pressure. So pressure multiplied with area minus, what can I write to the top surface? Can I write it as rho L into G into X into A? And this will be equal to, what is going to be the mass of the substance? Mass of the substance will be equal to density into volume. So density into volume is going to be A into H, and here it is going to be G. So G will get cancelled. So this rho is going to be the density of solid. Right. Similarly, A will also get cancelled. So what I left out with? So what are you left out with? Okay, I'll do one thing. Guys, I'm not sure if you're able to understand or is there any doubt. Give me a confirmation. Is it clear to the step F2 minus F1 is mg? Is that step clear?
Yes, sir.
Okay.
Yes,
Now
sir.
to put it simple, F2 minus F1 is what is called as upthrust. That you're accepting. So difference in the upper force minus lower force. So difference in the lower force minus upper force is what is called as upthrust. This upthrust is equal to the weight of the object. That's what it says. Right? So that is the meaning. So this is one way, or how you can prove is see. F2 is how much pressure at point 2 into area of point 2. Can I write it like this? So what is the pressure at point 2? It is rho g into h plus x into what is going to be the area of 2? It is, let me take it as capital A. Similarly, what is going to be the value of F1? It will be P1 into A1. So this will be equal to rho g into x into A. So this F2 minus F1 is going to give us rho g into A into h plus x minus x. So x and x are lost. So you will get rho g into capital AH. So A into base area multiplied with height is going to give you the volume. So rho into V into G is going to be the weight. So this is going to be the weight of the liquid displaced. That's it. Okay. So the next part that they will ask you is something called as apparent weight. See, apparent is always the changed value. So apparent weight is given as weight of the object minus upthrust. So weight of the object minus upthrust. So weight of the object is given as density of solid into volume of solid into G minus upthrust is given as density of liquid into volume of immersed portion of liquid into G. Okay. So this is what is called as apparent weight.
So what is the
Sorry.
what is the age?
Voice is breaking again now.
Sir,
Can you
what is
drop?
that VI, sir?
VI is the volume of immersed portion.
Okay, sir.
Volume of immersed portion of solid. See, whatever is the volume that is immersed into the liquid, right? That is what is called as VI. Okay. Next is fractional submerged volume, fractional submerged volume of floating body. Okay. So let's say there is an object there is a solid which is immersed into the students, just give me 2 minutes. I had a power cut here. I'm logging to another device. So what was the topic? I wrote a heading, no? What was it? Fractional part of the submerged volume, right? See, suppose I take a liquid in a container in this way. And let's say there is a solid that is getting immersed in such a way that this is going to be the volume of the immersed portion of the solid. Okay. Weight of the solid is acting downwards and there is a buoyant force acting upwards. So mg will be equal to buoyant force under equilibrium condition. Right. So what is going to be the value of mg, that is the density of solid into the volume of solid into g, is equal to buoyant force is given as density of liquid into volume of immersed portion of liquid into g. G and G will get cancelled, which implies volume of immersed portion divided by volume of solid is equal to density of solid divided by the density of liquid. Okay.
So can you repeat?
Come again. V higher. Harini, for some reason your voice is breaking now. You have to come online. I mean, drop me a message. What should I repeat? The whole concept. See, listen. M is density of solid into volume of solid. This is the mass into G is equal to, what did I say the buoyant force according to Archimedes principle is? It is the density of liquid into volume of the immersed portion of liquid into G. So G and G will get cancelled, which implies volume of immersed portion divided by the volume of solid will be equal to the density of solid divided by the density of liquid. And this volume of immersed portion by volume of solid is what is called as the fractional part.
Okay, sir.
Yeah. So I'll tell you where it will be useful. See. If you're done with this, I explain it. See. A solid body floating in water has 1/6 of volume above surface. Okay. What fraction of its volume will project upward if it floats in a liquid of specific gravity 1.2.
So read the question carefully, you will get the answer. So if you read it, the question says there is a liquid like this. Okay. And in that liquid, there is a solid that is immersed, so that V/6 volume is outside. So what is the volume that is present inside the surface? So what is the volume present inside the surface? Is it not 5V divided by 6? Yes or no? So that's what they told, no? V/6 of the volume lies above the surface. Now, what is a fraction that is above the surface is what they're asking. Means I need to calculate what is the volume of the immersed portion to the volume of the solid itself. How much will the answer be? Or how do I even approach? So we know that solution, we know that buoyant force is equal to weight of body, right? So what is the buoyant force? It is the density of liquid into volume of the immersed portion of the solid into G is equal to what is going to be the weight of the body? It is going to be the density of solid into volume of solid into G. So G and G are lost. So what is the density of liquid that is given? What is the meaning of specific gravity? Specific gravity is also called as a relative density. The meaning of specific gravity is it is a density of solid by density of water. So that will be 1.2 divided by 1000 into volume of immersed portion is equal to what is the density of the solid? That they didn't give, no? So density of solid, they didn't actually give. But let's see. Density of solid into
Sir,
volume of,
can you explain what relative density, like specific gravity is again?
so write it down. Specific gravity is also called as relative density. So the meaning of this is it is the ratio of density of substance by the density of water at 4 degrees Celsius.
Okay, sir.
Okay. Yeah. So I hope you understood this equation. Rho L, density of liquid into volume of immersed portion into G is equal to density of solid into volume of the solid into G. So what should I write in the place of volume of immersed portion? So how much is the volume of the immersed portion? I need some response, guys.
5V/6.
So it is 5V by 6 is equal to what is going to be the density of the solid that they have not given. So can I write it as rho itself into what is going to be the volume of the solid? It will be V. So V and V will get cancelled. From here, what can we say? Rho is equal to. So this will cancel this 1.2 times. This and this will get cancelled. So rho is 1 by 1000. Oh, I'm sorry, guys. Sorry. Density of the substance is 1.2 into 10 power 3. That is 1000. So 1.2 and 1.2 will get cancelled. So rho will be equal to 1000. So it is 1000 kilogram divided by meter cube. That is the density of solid. So having said this, read the question carefully. They asked what fraction of its volume will project upward. So what fraction of its volume will project upward means volume of the solid minus the volume of the immersed portion divided by the volume of the solid is how much? This is what they are asking actually. Okay. So I'm not sure if you're able to, are you guys with me or not? Nobody is speaking. Is it clear or is there any step that you want me to explain?
Sir, can you explain why you wrote 1.2 into 10 to the power 3?
No, it is because of this. 1.2 is equal to density of substance divided by density of liquid by density of water. Density of water is 1000, so it will get multiplied, no? So density of liquid will be 1.2 into 10,000. That is why 1.2 into 10 power 3.
Sir, so what you had written before is a mistake, right?
Yeah. Now it's fine.
Yes, sir. I didn't understand why you changed it.
Yeah. It is because this value will get multiplied. I got a doubt because density came as 1 by 1000. It will not come as 1 by 1000. Okay. So Vs minus Vi divided by V. So how much is it going to be? So it will be 1 minus Vi divided by Vs. It will be 1 minus wait. Okay. See, I'll do it in 2 steps. Did you guys read the question? Did you understand? Can someone speak, please? Like, I'm really getting bored to take this. Can someone speak? Only one girl is speaking with me. Are you guys able to understand or not? At least tell an yes or no. I already don't have power here. That is why I'm not able to come with a video call.
Yes, sir.
Are you guys? Yes. So read this question carefully. There is a solid object which is floating in water, has 1/6 of its volume above the surface. Okay. So I'm doing it again. Listen. Volume of solid, if I take it to be V, so if I take this volume of the solid to be V, okay. First case, what is happening is the solid is immersed in water. So when it is immersed in water, volume of the immersed portion divided by the volume of the solid is how much? Volume of the immersed portion is 5 by 6 by V. And volume of the solid is going to be V. So V and B got cancelled. It was 5 by 6. Now what they're asking us is, if the same solid is taken into and other liquid whose relative density is 1.2, then how much is going to be the volume of the immersed portion? In this case, what is going to be the volume of the immersed portion divided by volume of solid? Okay, that is what we need to calculate. So observe, density of solid into volume of immersed portion of solid into G is equal to density of, into volume of solid into G is equal to density of liquid into volume of immersed portion into G. G and G will get cancelled. So I'm calculating from the first case what is going to be the density of the solid, because we don't know the density of solid, right? Did they give us? No. So how do I calculate the density of solid from this scenario? So density of solid into volume of solid into G is equal to density of liquid into volume of immersed portion into G. Cancel this and this. So density of solid, I'll write it as Vs, rho S, and the volume of the solid is obviously V. This will be equal to, tell me, this will be equal to what is going to be the density of the liquid in the first case? Water. So 1000 into what is the volume of the immersed portion? It is 5 into V divided by 6. So V and V should get cancelled. What should be the answer for the density of solid? So density of solid will be equal to 5000 divided by 6 kilogram per meter cube. Is this point clear?
Yes, sir.
Okay. Now the next question is, for me to calculate this value, can I write it as density of solid into volume of solid into G is equal to density of dash to volume dash times G and G will get volume of solid, it is divided by 6. If the volume of the solid to be V, this will be equal to the density of the new liquid is going to be 1200, sorry, 12,000, 12,200 only. Because why is it so? Because it is 1.2 into 10 power 3 into volume of the immersed portion dash. So 0, 0, 0, and this will get cancelled. So what is going to be the volume of immersed portion divided by volume? It is going to be 5 by 6 into 1 divided by 1.2, or 5 by 6 into 10 divided by 12. Right? If I multiply with, so 5 by 6. So how much is going to be the answer? 25 divided by 36. So 25 divided by 36 is the volume present inside the surface or below the surface. Now, what is the question? They didn't ask us what is the volume below the surface. What did they ask? What fraction of its volume will project upward? So what is the volume that is going to get projected upward? It will be 1 minus 25 divided by 36. That is going to be 11 divided by 36. So this is the fraction of volume that will be projected upward when the same solid is immersed into a liquid of specific gravity 1.2. Okay. Did you all copy? Can I give one problem that you can try based on this? So write down this one. A body has mass 6 kilogram. A body of mass 6 kilogram is floating in a liquid with 2/3 of its volume inside the liquid. Okay. Find first the buoyant force. Second, ratio of density of solid to density of liquid. Okay. And take the value of G is equal to 10 meter per second square. Do it fast and tell me. Anybody with the answer? So what is the answer? A body of mass 6 kilogram is floating in a liquid with 2/3 of its volume inside the liquid. So how to do this? Mass is equal to 6 kilogram. Volume of solid inside the liquid. So volume of the immersed portion is 2/3 times V. Find the buoyant force. So what is the formula for buoyant force, guys?
mg.
No. Buoyant force I already gave you, no? Everywhere we are applying the formula. It is the density of liquid into volume of immersed portion of solid into G. At least now solve and tell what is the liquid that is there. So liquid density is not given. So how do we solve it smartly? What are you people doing? Relaxed? See, what is the formula for buoyant force? It is equal to the weight of the liquid displaced.
So the weight of the liquid displaced is 4 kilogram.
How do you say it is 4 kilogram?
Sir, because the mass of the object is 6 kilogram and the amount that is immersed inside is 2 by 3.
Okay. But see, this is where I wanted you to be more clear. Good that you tried it. See, this is 2/3 of the volume, right? So what we need to do is, did you take the density of the, how did you get your 4 because of this 2/3?
Yes, sir.
Is that what you're, no, that is not how you're supposed to. This is what I'm trying to correct. So density of liquid, buoyant force is actually coming into picture because the liquid is getting displaced. So that is why if you see, it is actually given like this. It is the density of liquid into volume of solid immersed into acceleration due to gravity. Right? So here observe, two different objects are there. One is a liquid and the second is a solid that is being immersed. Is that point clear? Now, if that is
Yes.
the case, you can only take the volume of the solid immersed is actually 2 by 3 times V. But we don't know the density of liquid. We don't know the density of liquid. So here I'm expecting you to understand what is the meaning of this word floating. So what is the meaning of the word floating? So when you see the word a solid is floating, it means it is like it is in equilibrium. Okay. So when the solid is in equilibrium, what is the force acting downward? It is the weight of the object which is balanced by the buoyant force. Right? So buoyant force, what can I write as? It is going to be weight. Who told mg? Who told mg in the beginning? Okay. So what is going to be the weight of the solid? It is going to be 60 Newton. So 60 Newton is going to be the buoyant force. Right. Now, if I take this value 60 and equate it to, so they ask the density of the solid to the density of the liquid. So rho S into volume of solid into G is equal to rho L into VI into G. So G and G will get cancelled. So density of solid divided by the density of liquid is equal to volume of immersed portion by volume of solid. So volume of immersed portion is going to be 2/3 of the volume divided by the total volume. So V and V will get cancelled. Answer will be 2 by 3. Okay. Is the point clear?
Yeah, sir.
Good. So with this, fluids at rest is over. Now we'll discuss about the fluids in motion. That is fluid dynamics. Okay. So when I talk about this fluid dynamics, right? First, we will try to understand the term called as viscosity. So viscosity is basically friction in fluids, especially liquids. Okay. So when yesterday I told you, right? When you take a liquid that is flowing, divide it into multiple layers. Okay. Divide the liquid into multiple layers in such a way, then when a liquid is actually flowing, there is going to be a contact existing between the subsequent layers that are in connection, right? So when the liquid is flowing, there will be a property that will come into existence in such a way. So property of liquid by virtue of which there is a friction that comes into picture to oppose the relative motion between the layers. Okay. Then this frictional force is what is called as viscous force or viscous drag. The force is called as viscous force or viscous drag. Okay. And this viscous force or viscous drag obviously acts tangential to the surface. Right. Now, here is where I'm going to explain you an important concept. Listen to this carefully. Suppose I have a fixed surface. So on the fixed surface, let's say there is a fluid that is taken into consideration. Actually, it is not like the surface is fixed only at one end. Imagine a pipe, okay? Imagine a pipe through which liquid is flowing, where I've taken only one end of the pipe and I'm trying to analyze the motion. Then what will happen is there is the first layer of liquid which is in contact with have velocity approximately equal to 0. Okay. Next, what will happen is if I have a layer here, then here the velocity will be v. For instance, I'm calling it as v. Okay. Then as I go above, the speed of the liquid will be v plus delta v. Then above that, the speed of the liquid will be v plus delta v twice, or v plus 2 times delta v, because as you keep moving away from the fixed surface in the upward direction, you can see that the speed of the layer will be slightly greater than the layer below it, because that layer, the top layers are being away from the fixed surface. Means the fixed surface is the one which is going to exert the maximum amount of this frictional force on the liquid, right? So this is how there is going to be a viscous force acting between the subsequent layers that are present in the system. Okay. So based on this, we need to derive certain parameters like
See, 1 minute. I got power back. 1 minute. Try to connect it to the system.
Recording in progress.
Now it will be easy. See. Now the next concept that we are going to see is coefficient of viscosity, which is given by the symbol eta. See, I told you that there are layers, right? So if this is a fixed surface, as you move away from the fixed surface, the speed of the liquid is going to increase. Now, what I'm saying is, if I consider two layers of this sort, okay, in such a way that the speed of the bottom layer is V and the speed of the layer above is V plus delta V. Okay, for instance, and let me say this is going to be the fixed surface. So if I take this height to be X and the height above to be X plus delta X, I hope you're able to understand this. Then the difference between these two layers is going to be delta X, right? So compared to these two layers, what direction is the viscous force going to act? It is going to act in the opposite direction. It is going to oppose the motion, obviously, right? So based on observation, what we can say is the following points are taken into consideration. First thing is the viscous force that is acting is observed to be directly proportional to the area of contact. Okay, there it is directly proportional to the area of the layers in contact. Second, F is observed to be directly proportional to delta V divided by delta X. Okay, so remember in physics or math, you have heard this word gradient. You would have heard this word gradient, right? I myself would have told many times. So gradient is also called as slope. Okay. See, there are two kinds of quantities we define, delta V by delta T or delta V by delta X. So where V stands for velocity. So this is given a prefix called as rate. This is given a suffix called as gradient. So try to understand this. The first one is called as rate of change of velocity. And the second one is called as velocity gradient. Okay, what is this called as? It's called as velocity gradient. So whenever the denominator is change in displacement, you call it as gradient. Okay, so when you have this velocity gradient, what we can say is F will be directly proportional to A into delta V divided by delta X, which implies F is equal to negative of eta into A into delta V divided by delta X. And this is what is called as coefficient of viscosity And the negative sign here indicates that it is a opposing force. Is this point clear, guys?
Yes, sir.
Yes. So this is an important expression for you to remember. Right. So having said this, observe. Can I write something like this? Okay. So what is going to be the value of eta? It is going to be F into delta X divided by A into delta V. F into delta X divided by A into delta V is what is going to be this value. Now, what is going to be the
What
S?
happened to that negative symbol, sir?
I took only the magnitude. I'm concerned about the unit of eta.
Okay, sir.
Yeah, what is going to be the value? It is going to be Newton, that is kilogram meter per second square, into delta X is measured in meter, divided by the area is measured in meter square, and delta V is measured in meter per second. So meter square, meter and meter, one value is going to get cancelled. It will be kilogram meter inverse second inverse. So this is going to be the SI unit for the coefficient of viscosity. Okay. Now, what is going to be the dimensional formula of it? Dimensional formula will be M L minus 1 T minus 1. So this is going to be the dimensional formula, right? Now, see, if I write this force in terms of Newton itself, then I'll have Newton meter divided by meter square into meter per second. So meter and meter are lost, which implies it is going to be Newton meter power 2 second. What is it called? Newton meter power minus 2 into second. Then this value is given a name called as decapoise, or it is also called as poise. It's also called as Poisson. Okay. Similarly, if I have to write the same thing in terms of CGS unit, what will I get? I'll get it as dyne centimeter power minus 2 second. Right? Then this value is called as simply a poise. Okay. So a relation between poise and decapoise. Obviously, deca means how much? It's 10. So 1 poise will be equal to 10 decapoise. Okay. So poise or decapoise is another unit for coefficient of viscosity. Clear with this?
Sir, sir, can you explain what exactly is viscous force?
What exactly is?
A viscosity, sir. Like you
Viscosity
told,
is
it's friction, right?
it's a frictional force. It's a viscosity is the property of the liquid where each layer is exerting a force on the other to have a relative motion. when there is a relative motion existing between different layers, which is opposing each other, then that kind of a force is called as viscosity. If I have to put it in very simple terms, okay, if I have to answer in simple terms, friction is an opposing force in solids. Viscous force is an opposing force in liquids. That's it. So it has the same functionality as that of friction, except the fact that friction acts between the layers of two solids, viscous force acts between two liquids, the layers of liquid. Are you able to understand this? See, if I have suppose I have a slope like this. Okay. Let's say it is a wood. Okay. Let's say you take a wooden piece and place it in the inclined position. And here you put a drop of water. Right. What will happen? What do you think will happen? Shri Kriti, what do you think will happen?
Sir, the drop will slide down.
It will slide down. But when it is sliding down, right, you can see some portion moving fast and some portion being stuck at this point itself. Are you able to
Yes,
understand
sir.
what I'm saying? So my question is, had it been only a solid, right? See, for example, had it been a spherical ball, after some time, where would you find the complete spherical ball? Maybe somewhere over here.
Yes,
But
sir.
what happens in the case of fluid? When you drop a water, you can observe that there is some water that is stuck there at a particular point, and there is some amount of water that is actually flowing. Why is that water drop mark present at the place where you dropped it? Because the solid is a fixed surface. So in the liquid drop itself, in the water drop itself, if you go on a microscopic level, can you break it down into multiple layers, of which the very first layer at the bottom is actually in contact with that fixed surface? That is why you're able to see that wetness there, correct?
Yes, sir.
So as you move away, right, you can see that the topmost layer will move faster. So that is a concept from which they came with an understanding saying that the layers among the liquid itself, when you break the liquid surface into multiple layers, each layer will exert a resistive force on the subsequent layer. And that resistive force that is offered by the liquid surface is what is called as viscous force. And that phenomenon is called as viscosity. Clear with this?
Yes, sir.
So in this, what we did is, when we try to calculate the coefficient of viscosity, it is something similar to the coefficient of friction. So when we discuss coefficient of friction, what did I tell you? The frictional force is directly proportional to the normal force exerted by the surface. Then you wrote F is equal to mu into N. What did you call this mu as? You called it as coefficient of friction. In a similar way, when you observe for a liquid, these are all the parameters that were concluded. You can say that the viscous force acting directly depends on the area of contact. Area of each liquid layer that is in contact. So more is going to be the area. They are saying more is going to be the viscous force. That is why F is directly proportional to A. Similarly, one concept we understood, as we move away from the fixed surface, the speed of the liquid layer is increasing. That is why speed of the first layer, I took it as V, and the speed of the second layer, I took it as V plus delta V. Actually, they both are subsequent layers only. But for me to explain it diagrammatically, I had to take it in that way. Then we observed that there is a frictional force acting exactly in the opposite direction. And how is this frictional force with respect to delta V and delta X? It is directly proportional to delta V divided by delta X. Delta V by delta X is a single parameter, which is given a name called as velocity gradient. Now, if you combine this and this, you will get a new expression in terms of proportionality. Then what can you do? You remove the proportionality, you are going to get a constant. And that constant is given a name called as coefficient of viscosity. Then what we did is we tried to find the SI unit of coefficient of viscosity and CGS unit. Then we tried to find the relation between the SI and the CGS unit. So to put it simple, SI unit, CGS unit is going to be poise and SI unit is going to be decapoise. So like how you replace Newton meter with joule, you can replace Newton meter power -2 into second with decapoise. Similarly, you can replace dyne centimeter power -2 into second with poise. Got it? Are you getting a slight grip of it? What I'm trying to say?
Yes, sir. Sir, but in solids, friction is not dependent on area of contact, right?
There it is not dependent, yes.
Here it is
So-
dependent.
Here it is dependent. See, for example, if you take a brick is going to be in the shape of a cuboid. So whether you are going to place the brick like this and pull, or like this and pull, or like this and pull, it is going to be the same frictional force. That is for solid. So that is why it is independent of area. Whereas here, it depends on the area because it is happening between the subsequent layers of the liquid. It's not a complete substance against a complete substance. It is a force within itself. Okay.
Yes, sir.
Okay. So there are actually two more concepts based on this. One is called as Stokes law and terminal velocity. Those are simple only. So anyways, you guys asked for it. No, I have already recorded 2 videos today. So hopefully you should get those recordings by tomorrow or maximum by Sunday morning. I'll give it. Okay. So shall we wind up?